Think Squad is made possible by AT&T, investing to bring wired and wireless internet to America's communities, because the future has always been our business. AT&T, your world, delivered. The American Honda Foundation, a proud sponsor of Detroit Public Television's Think Squad project and committed since 1984 to improving science and math education for youth across America. To learn more, go to www.foundation.honda.com. And from contributions to your PBS station from viewers like you. Thanks.
People say science can be a real drag. I say that's just because they don't have the right support. I'm Alexis. I'm the leader of the Think Squad. We help kids solve problems, all kinds of problems. I've got a good team. There's Christopher. He's my right-hand man. He doesn't say much, but he misses even less. If there's something worth knowing, it ends up on his clipboard. Then there's Cameron. She's a reporter for the school news. During her interviews, she always finds a way to slip in a few extra questions for me. And when it's time to test that hypothesis, that's where Gary comes in. If he's not building something, he's probably taking it apart. Luckily, Sam's around to make sure he doesn't blow his goggles off. But don't get to thinking we're here to do your homework for you. No way. We provide the method. You provide the conclusions. We'll even fire up the think tank to help you sort everything out. What's the think tank? Don't worry. You'll find out. Just call the Think Squad. There's no problem we can help you solve.
You got my notes. Don't worry, you're not too late. It's just that I like to be early. I learned it's the best way so I won't be late for my next appointment. That reminds me. Huh. I can spare about 3 minutes. How long does this usually take anyway?
That depends. What exactly do you think this is?
Well, I have a problem.
That's good, because problems are our specialty. Maybe we should do this another time.
My dad always said there is no bad time for anything, and a good officer always finds time for everything. And they're never, ever late. Sorry, he should know. He was in the Navy. Where was I again?
What about the clocks?
Right, they keep breaking, and nothing else in my house has this problem. So of course, no one believes me.
And what does this have to do with your dad?
They were his when he was an officer. He's kind of obsessed with time, you know, normal dad stuff. At first, they all worked great, but I swear some even go faster before they die out.
And this isn't happening to anything else in your house?
No! Oh, I have to go if I want to be early for dance class. I can just leave this stuff here, right?
Of course, but I mean, we'll need to meet again.
So you think you can help me?
You've come
At a bad time. I know, but you were late. Just text me your answer when you decide.
You've come to the right place. The Think Squad will definitely take your case. You can come out now. She's gone. Okay, hit it. And there it is. Each one definitely broken. So, where do we start?
Might I suggest a 3/16" Phillips head screwdriver?
How about first we figure out what we're looking for?
You know, it's really funny. It's questions like those that usually end with me not tearing something apart.
I read that plug-in alarm clocks have been popular for over 50 years.
Yeah, thanks. Great history lesson. Problem is, our problem is here and now in the present.
My point is that this technology has been around for a long time. So it's really weird that all of these clocks would be defective.
Until we meet again, my little friend.
Okay, so based on what we know, it might not be that the alarm clocks are broken. It's more likely that the same thing is happening to all of them. But our client is sure that everything else in her house is working fine.
Is that all she said?
That's as much as I could get out of her.
How long did you guys talk?
3 minutes and 11 seconds exactly. But that was enough time for us to figure out what questions we need to start asking. And you guys know the rest. Scientific method. Let's establish the problem.
Something is killing time.
We collect data out in the field.
And then we formulate a hypothesis based on what we find out, assuming that she can fit us into her schedule.
And we test it.
Looks like my story might be a little bit shocking this week. Too much?
Easy. I look forward to your report.
We're keeping you current on the scientific world around you. Hello everyone, I'm Ashley.
And I'm William. Thanks for tuning in. Your Y News update starts right now.
Electricity. It puts the toast into your bread and the light into your light bulb. It even puts the us onto your TV screen. But how?
If you look around right now, there's probably an electrical outlet inside. But have you ever wondered what you're really plugging into?
For more than a century, electricity has been pumped into our homes and our businesses. By now, we take it for granted. But isn't there more to know about this amazing force?
Like, how does the power get there? Does it go back or just get used up on the spot? How does it make everything work? And what's going on when it doesn't work at all?
So before we overloaded with questions, we sent Y News reporter Cameron into the field to illuminate us.
Thanks, guys. We use electricity every day, but do we ever stop and think about how it really works? And if we know more about it, could that help us in cases when it doesn't? I'm at DTE Energy to find someone who could shed some light on the subject.
Hi, I'm Cindy.
Hi, I'm Cameron.
Nice to meet you, Cameron.
Thank you for meeting me here. I met with Cindy Norland, an engineer at DTE Energy. Cindy grew up in the Upper Peninsula and attended Lake Superior State and Lawrence Tech before joining DTE. She is currently the Director of Renewable Energy Construction and has spent the past dozen years building, modifying, and maintaining substations like this one in Westland. Pretty enlightening stuff, and it further sparked my curiosity.
We're at Newburgh Substation in Westland, and what this facility does is distributes power out to thousands of people in this neighborhood. We have hundreds of these across the system, and what they do is they take a higher level voltage and steps it down to a voltage that we distribute across the neighborhoods and businesses in this area.
I mean, that sounds pretty complicated. So what do you mean by stepping down?
So stepping down, we take higher level voltages through transformers to a lower level voltage. The station that we're in is taking 120,000 volts, stepping it down to 40,000 volts. And then it comes over here, steps down from 40,000 volts to 13,200 volts, which is the distribution system that we use out in this area.
Okay. I mean, all of this power, it sounds pretty dangerous.
Yeah, it is. And instead of me telling you about that, how about if I show you something?
Okay.
Show you a demonstration of it.
All right.
Cameron, I'd like to introduce you to Chris Fleming. Chris is a lineman here at Detroit Edison and runs our Arcs and Sparks demonstration. Going to help answer your question.
Hi.
It's a pleasure to meet you, Cameron.
So what exactly is this right here?
Well, Cameron, this is a transformer, and this is what we at the utility use here, and this is what produces the voltage that goes inside of your homes. We produce high voltage out there on our distribution lines, and they come into the top side of a transformer, and we produce the low voltage out the bottom side, which is called our secondary voltage, which is 120, 240 volts. In a normal situation, a transformer works every day, no problem. But in a bad way, a transformer can produce high voltage out the top side. And if you could, please step back, and I'll show you what could happen. We have to wear a lot of safety equipment here at Detroit Edison, and one of the things we're going to put on is our safety sunglasses, because the arc is going to be quite bright in that. What happens out there with electricity, you might think that it could jump out at you. How many people think electricity can jump? As you can see, it's not jumping right now. Go ahead, Max, you can turn on the probe. Electricity is not jumping across. I'll get it down about 3 inches, ½ inch, ¼ inch. Electricity will jump at about a 32nd of an inch, as you're going to see here in a second. Go ahead, Max, you can shut it off. You probably wonder how I keep myself safe while I'm working here. What I have on is a pair of rubber gloves, and these rubber gloves are rated and tested at 19,000 volts, Cameron. We make sure that these gloves are in good working order, and I'm going to show you a glove here and test it and make sure that it's in good shape. Got a little probe here. We're going to stick it on top, and we're going to try to draw an arc like we just showed there. Go ahead, Max, turn it on. As you can see, electricity is not traveling through this glove at all. Go ahead, Max, you can shut it off. Well, what Max is going to do now is he's going to take a small pin and put a small pinhole in this glove. And as Max is putting that hole in the glove there, what happened to a lineman out there is if he puts a small pinhole and he doesn't find out that the actual hole is in there, if he was to grab a hold of this power line, it could be a very dangerous situation. So now with the pinhole in there, we don't have any volunteers out here, so we're going to have to use our own volunteer, and it's a hot dog. A hot dog is kind of like your finger, and we're going to use this number 2 piece of copper to act like a bone. And then we're going to slide the hot dog as your finger back into the glove and show you what could happen if you don't have the proper safety equipment on while you're working on high voltage lines. Go ahead, Max. With the small pinhole, electricity will jump through that glove very fast, as you can see. And the reality of electrical burn is what you're going to see on this hot dog very quick.
Well, thank you so much for meeting me here and showing me this substation. I mean, I never realized how the whole world got their power like this.
Well, actually, the whole world doesn't get their power the same way.
Really?
Yeah, I've got something I could show you.
Okay.
Well, Cameron, this is the room I wanted to show you. It's got various electrical meters that we've used across our history. It also shows outlets that are pretty common in our system, starting with the standard wall outlet that's 120 volts that you'd plug an alarm clock or a cell phone charger or something like that into, all the way through various appliance outlets. For instance, this one you'd plug a stove into, an electric stove that's 240 volts. I was explaining how the world is not all the same. And I have a couple examples here of devices that are used by travelers as they go to various parts of the world. And you can see even by the prongs on these that go into the outlet that this would be the standard one like you'd see in the United States here. But this would be one like you'd see in Northern Europe, and you can see that they're round versus being the flat square ones. And you use these along with a converter device, and it allows you to take your appliances from here and use them in other countries around the world.
You heard it here on Y News. Who would have guessed that behind those little outlets is such a big story? It's a good thing we have engineers like Cindy Norland to keep us out of the dark. For Y News, this is Cameron.
Have you ever been wrongly accused? Do you have a hard time convincing people you're telling the truth?
But I wasn't cheating.
Do you need someone to prove your case?
You better think smart. If you're innocent, there's nothing to it. They are ready to help you solve any problem. Trust me, they prove that my dog actually ate my own.
There's no problem we can't solve.
Thanks for meeting me here this morning. I woke up late and I'm way behind. Any luck on getting me back on schedule?
We have, but if we're gonna go further, we're gonna need your help. And unless you're in the mood to spend the rest of your life sprinting around, I'm going to need you to focus.
Okay, sorry. It's just sometimes I get a bit overloaded. I can spare about 5 minutes.
It might take longer than that. It's best not to rush the think tank.
This is the think tank. It's where you can access all of our information we have about how.
Sorry. I'll just put this on vibrate. By vibrate, I mean off. I was switched off.
And why your things keep getting zapped.
How?
And why. Think tank, please load electricity report.
Electricity moves in a circuit called a current. The most basic current has a source, like a battery, a load, like a light bulb or an alarm clock, and 2 wires. The wires carry electricity between the battery and the load. Electrons move from the source, through the load, and back to the source, doing work along the way, like lighting up a bulb or running an alarm clock. A source of electricity will have 2 terminals, a positive terminal and a negative terminal. The source pushes electrons out of its negative terminal to the positive terminal.
So, what if my alarm clock is messed up?
Good question. Why don't you ask?
Think tank, what if my what if my load is messed up?
For appliances to run on electricity, the power of the current must be constant. If the current is too low, the load will not function. If it is too high, there is a risk of a burnout.
Think tank, define burnout.
Burnout is the result of too much power or overcurrent. It can burn away the wire's insulation, making it incapable of carrying the voltage it once carried. Thus, a device experiencing overcurrent would be getting more electricity than it can handle and would likely stop working.
Burnout, that's it. Something in my room is giving my clocks too much current and it's killing them. But how can that happen? Think tank, how can a current change?
Every country on Earth is wired somewhat differently, and homes in the United States are wired a certain way to run all of our appliances. Some outlets in our houses are specially designed to run big appliances that carry a heavy load and need more power, like refrigerators and air conditioners.
So, any chance you're plugged into one of those?
I don't think so, but at least we know what to look for.
Really? You feel like you're ready to make a hypothesis?
Yeah, you heard it yourself, didn't you? The clock's just getting too much current. We have to look inside of them.
All right. So what's your hypothesis?
That somehow all the clocks are getting too much current, and that's causing them to burn out. So, like the talking wall said, the only way to know for sure is to open them up and look for signs of an overload, like a fried wire. But who in the world can do that?
I think I know someone, and you just made his day.
What is it about a giant plasma globe that seems to take the edge off a long day of solving scientific mysteries?
It's the gas. I find it exciting. Argon, krypton, and xenon gives it the best color.
I totally have to make one of these.
So, ready to learn about some electricity?
Does it involve dissecting a clock?
Not exactly.
Not interested.
I see. Well, what about if I show you what would happen if we put 15,000 volts of electricity into a tiny little wire?
After you. So what's gonna happen?
Don't just ask what, ask why.
But isn't why meaningless without what?
But isn't what meaningless without... The wire's gonna disappear.
Why?
See this wire in here? It's attached to 2 things called nodes, and I'm gonna charge up that capacitor with thousands of volts of electricity.
Volts?
Yeah, volts are a measure of potential energy in an electric current. It's almost like pressure pushing water out of a faucet.
Oh, so I get it. The bigger the charge down here, the bigger the current up here.
Exactly. And the amount of work a current can do is measured in watts. For example, it takes 60 watts to light a normal light bulb.
And how many watts are we going to be pumping through this wire here?
About 300 million. We better back up.
Whoa. Again?
No.
So, if all that electricity vaporized the wire, then what are we looking for in these clocks? No wires?
It's highly unlikely, even in the event of an overload, that enough electricity could be generated to explode a wire inside of a clock. But there must be some evidence of it on a smaller scale, like if...
What?
You know any Japanese?
All right. So we have no sign of burnt wires or overcurrent or of an overload. In fact, our experiments confirm that those clocks are getting exactly the amount of electricity that a standard American wall outlet would produce.
So, what? Did my dad do this on purpose to teach me a lesson?
Is that really where the facts are leading you?
Why else would he send me clocks that don't work? As busy as he is, as far away as he is, do you know how much it costs to mail packages from Tokyo?
So maybe there is an electrician who specializes in like foreign appliances.
Engineer too. Yeah, engineer. They could team up and they could be like with.
Yeah, because there's something that we're missing. I think it's something technical, something that he wants. An electrician. Maybe you can tell us something that we didn't see before. Go back on the field. Ask them almost everybody.
Right, I could do that, but I just don't get how, because if it's the same as Japan as America, that's an easy thing to check.
Wait a minute. Is it too late? Hello, is it too late?
Too late for what?
To go to the think tank. I have another question. Think tank. Do different countries run on different electrical systems?
Different countries operate with different voltage, and just about every country is different.
Compared to the US, how different is the electrical system in Japan?
The electrical system in Japan is the same as in the United States, in the western part of that country. However, in the eastern part of Japan, the electrical system is different.
That's it! My dad! He was stationed in Japan. He must have bought those clocks there. Think tank. What would happen if a clock made to function in the eastern part of Japan was used in the US?
While the plugs on appliances used in eastern Japan are identical to those in the US, the electrical system runs on a lower frequency. As a result, an appliance from that area would be able to plug into an American outlet, but could experience problems such as running too fast or breaking down.
Congratulations. Looks like all that's left is to tell your dad to find a new place to shop.
Yeah, it figures. He's always in such a rush. I bet he never took the time to realize those clocks wouldn't work here.
Funny, isn't it? Sometimes all we need to do is slow down and the answer will be right in front of us.
Well, I'm here to confirm reports of a job well done. Another mystery solved, another member added.
It's a beautiful thing.
Yeah, but I can't help but thinking that this particular client had some outside help.
Well, I don't know. Sometimes the scientific method can move in mysterious ways.
Uh-huh. Sometimes when we're overloaded, we need a little extra help to fix our problems.
What's an electrician for?
Think Squad is made possible by AT&T, investing to bring wired and wireless internet to America's communities, because the future has always been our business. AT&T, your world, delivered. The American Honda Foundation, a proud sponsor of Detroit Public Television's Think Squad project and committed since 1984 to improving science and math education for youth across America. To learn more, go to www.foundation.honda.com. And from contributions to your PBS station from viewers like you. Thanks.